Okay, hello again. I want to make a video about what we can cancel when we're dealing with fractions. So let's start with an example. One question we may have is maybe we have something like x plus 3 over x squared plus x plus 1. A lot of students ask if we can cancel, I don't know, let's say we can cancel those two things there. And the answer is definitely no. We can't cancel those. And let me just show you a quick reason why. If we were to be able to cancel, then that would mean that the expression x plus 3 over x squared plus x plus 1, that should be equal, let's put a question mark over it, should be equal to 1 plus 3, if we were to cancel those. Or x squared plus 1 plus 1. So that's maybe if we cancel those out and make them both 1s. Or maybe you're curious if we can maybe cancel them both out to be 0. We'll see that neither of these is going to be true. And the way we're going to see that is just do a test case, right? If these things were really equal, then they should be equal no matter what x is equal to. And so let's just check x equals 5. I just picked that randomly to see. Well, the left-hand side is going to be, if we plug in 5, I think we're going to get 8 on the top, and I think we're going to get, let's see, that's 25 plus 5, that's 30, so I think we're going to get 31. So we get that fraction 8 over 31 on the left. And on the right, well, if we plug in x equals 5 on the right, well, over here we're going to get 4 over, let's see, that's 25, 4 over 27. And down here we're going to get 3 over 26. Right? So if we plug in x equals 5, we just get 3 completely different numbers. All these fractions are different. So none of these 3 expressions can be equal. Right? So whenever you are curious if you can factor something, a pretty good test is to just plug in a random number like 5 or 2 and see if the expressions you get would be the same after you plug that number in. It's not a surefire test because sometimes things might be equal coincidentally, but it's a pretty good test. So now we've talked about an example of when we can't factor. I'd like to emphasize that there's really only one time we can actually cancel. Right? So only one time we can really do it, and that's where we have factors in the numerator and denominator. Okay. So for example, if I have something like 2 times 5, and I divide that by something like 3 times 4 times 5, well, I'm gonna be able to cancel those two 5s. And the reason I can do that is because this is the same as just splitting this up as a product of 2 fractions. Right, I can put those two 5s together as like a separate factor here, because the way that multiplying fractions works, we just would extend this line across. So this gives us that, and we can see that 5 over 5, well, that's just the same as 1, right? So that cancels out to 1, and so we're just going to get 2 over 3 times 4. So when we have a factor that's the same in the top and the bottom, we can cancel it. And the same is true whether that factor is a number or maybe it's an expression like this. So let's just see how this goes. So maybe we have something like x squared, x plus 2, and then maybe minus 1 plus x. So in this expression here, we're looking for common factors. So everything seems to be factored in the top. We notice there's an x in the numerator and an x in the denominator, although there's 2 x's here. And so what some people might choose to do is to rewrite this x squared just as x times x. And once we do that, then we can completely identify some common factors and cancel them out. Let's see, there's the only other common factor that looks like it could be is this minus 1 plus x. We probably think it's either going to cancel maybe with this x plus 1 or the x minus 1 in the numerator. Turns out if we rewrite this, negative 1 plus x, well, that's the same as x minus 1. We've just written it in a different order. So I could, in fact, just maybe rewrite this as x minus 1, and then I can cancel those factors. So this is how we can cancel things when things are factored. Again, the main thing we want to just watch out for is canceling things like maybe x plus 1 over x minus 1. There's no way to simplify this. So you can't cancel the x's, you can't cancel the 1's. There's really no way to simplify this fraction because we only have one factor on the top and one factor on the bottom, and they're not the same. So that's basically it for factoring. I'll do maybe one more example just of something that's not quite factoring, but it might be useful. A lot of times we'll do something like maybe 3x cubed plus x squared plus x, and we'll divide that by x. And if we look at this, well, at the top there's only one factor at the moment, and that factor isn't the same as x. So we can't cancel anything at the moment, and we have a couple options. Let me just show you option 1. Option 1 would be to factor an x out of the numerator, and then we divide by x, and then we can cancel. So we would get our answer of 3x squared plus x plus 1. Option 2 would be to take this fraction. So let's rewrite that fraction. And let's split it up into 3 different fractions. So this is doing adding of fractions in reverse. So if we add fractions in reverse, we should check that if we got a common we have a common denominator on the right, so if we combine all 3 terms, we would get the expression on the left. And now we do have common factors, so now we can cancel, let's do it in a different color, we can cancel the x with x cubed and get x squared, cancel this to get x, and we can cancel this to get 1. And so at the end of the day, we get 3x squared plus x plus 1, and that's another way to do these simplifications. So thank you for watching, and see you soon.